Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this video, we're going to looking multiplying and dividing complex numbers. The idea of multiplying complex numbers is exactly the same as using the FOIL method. It's a little different simplifying at the end, but I think once you see this example, the idea is exactly the same. So let's get started right away. Here we have 5 plus 2i being multiplied by 4 minus 3i. So we want to use the FOIL method. So first I'm going to multiply 5 times 4. 5 times 4 is equal to 20. Now I'm going to multiply 5 times negative 3i, which is equal to negative 15i. And now I can multiply the positive 2i times a positive 4, which will give me a positive 8i. And if I multiply a positive 2i times a negative 3i, that's going to give me a negative 6i squared. And before we move on, let's go back and review for a second. We know that the imaginary number I is equal to the square root of negative 1. And if we square both sides of this equation, we get I squared on the left side, and on the right side, the square and the square root cancel out, and we're just left with negative 1. So we know that I squared is equal to negative 1. So every single place there's an I squared, we can replace that with a negative 1. And notice in our expression how we have an I squared. So I'm going to replace this I squared with a negative 1, and everything else in the expression stays the same. If we start on the left, we have 20 minus 15i plus 8i, and we have a negative 6 being multiplied by the negative 1. And now we just need to keep on simplifying as much as possible. On the left, we still have our 20, and in the middle, we have two like terms. We have a negative 15i, and we have a positive 8i. 15 plus 8 is negative 7i. And on the right, we have negative 6 times negative 1, which is equal to positive 6. So now we still have like terms. We have a positive 20, and we have a positive 6. So we can simplify this even further. 20 plus 6 is equal to 26, and we still have our negative 7i. So here is our solution to the expression, 26 minus 7i. Now let's go over an example where we divide imaginary numbers. So here we have 4 plus 2i divided by 3 minus I. And whenever you're dividing complex numbers, you can never leave an imaginary number in the denominator. So our first step in this problem is to get rid of this imaginary number in the denominator. And to do this, we need to multiply by the conjugate. And the conjugate is exactly the same as the denominator, except you change the sign in front of the I term. So instead of 3 minus I, we're going to have a 3 plus I. Notice how the sign in front of the I term is changed. And whatever you do to the bottom, you also have to do to the top. So we're multiplying the top and bottom by the conjugate 3 plus I. And now we have a whole bunch of foiling that we have to do. So I'll start with the denominator. In the denominator, we have 3 times 3, which is equal to 9. We have 3 times positive I, which is equal to positive 3i. And we also have negative I times positive 3, which is equal to negative 3i. And we have I times positive I, which is equal to negative I squared. Now let's do the same thing for the numerator. In the numerator, we have 4 times positive 3, which is equal to 12. We also have positive 4 times I, which is equal to positive 4i. We have positive 2i times positive 3, which is equal to positive 6i. And we also have 2i times positive I, which is equal to positive 2i squared. And just like in the last problem, we want to replace every I squared term with a negative 1. Because once again, we know that I squared is equal to 1. So I'm going to erase both I squared terms and replace them with a negative 1. So now let's simplify this as much as possible. I'm going to start with the numerator. On the left of the numerator, we have a positive 12. And in the middle, we have two like terms. We have a 4i and we have a 6i. 4 plus 6 is equal to 10. So we have a positive 10i. And on the right, we have a positive 2 times a negative 1, which is equal to negative 2. And in the denominator, we have a 9 on the left, and our positive 3i and our negative 3i cancel each other out. So we got rid of our I terms. And on the right, we have a negative and times a -1, which is equal to +1. So now notice how we have no more I terms in our denominator, which was what we wanted to do. That's why we multiplied by the conjugate. So now we got rid of the I terms and we just need to simplify just a little bit further. In the numerator, we still have two like terms. We have a 12 and a -2. 12 minus 2 is equal to 10. And we still have our positive 10 I term. And in the denominator, we have 9 plus 1, which is also equal to 10. And at this point, sometimes you can be finished, but with this particular problem, we can still factor. Notice how in our numerator, we have two terms that both have a 10 in common. So I'm going to factor out a 10 in the numerator, and we're left with a 1 plus I on the inside. And in the denominator, we still have our 10. And now the 10 in the numerator and denominator cancel each other out, and we're left with 1 plus I as our solution. So I hope this gave you a better idea on how to multiply and divide complex numbers. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.